So we got to read the problem, and then we have to decide which formula we're using. So here we go. Let's read 27 and see what's going on. Okay, payments. Are there payments?
No.
Every month, is he making a payment?
No.
No. So we're not going to use those formulas. So then we got to decide, is this a compound interest formula, or is this a continuous interest formula? Who signed that?
That's the technology.
So which is it? Is this a PERT, or is this our compound interest formula? Number 27.
Compound interest.
Compound interest. So we know which formula we're going to use. Now it's just a matter of getting all the right numbers put in the right spots. So here we go. What are we going to do with the 14.6?
Divided by 22.
Wait, I'm just putting it in right now. I'm not doing any work. Where do I put 14.6? That's P. And where do I put the 22? Do I have an interest rate? Nope, that's what I'm looking for. Do I know how often I'm compounding? How many times a year? Once. And how many years? So I need to solve this equation, all right? What do I do first? I'm going to divide. So I'm going to have 22 over 14.6. I'm sure that's something. Do I need logarithms? No. One more time. When do I need logarithms? When the variable is an exponent. Do not be logarithming anything in this problem. Okay, so what do I do?
You take the 6th root of...
I'm going to take the 6th root of both sides. Only when I type that into my calculator, I'm going to raise this to the what power? 1/6. And once I get that accomplished, all I'll need to do is what?
Subtract 1.
Subtract 1. So 22 divided by 14.6 raised to the parentheses, 1 divided by 6 power, and then minus 1. So it looks like my interest rate is about, well, the decimal is 0.0707, so that would be like 7.07%. That wasn't too bad. Mr. Allerding?
31.
31. Complete the table about continuous compounding. What formula? So I want to double my money. And I'm starting with $12,500. So what would I be ending with? 25,000. And the interest rate is 0.09. Time to double. How long does it take me to double my money? Got it, Mr. Allerdy? What do I do first?
Divide.
I get 2. Do I need logarithms?
Yeah.
So since this problem has an e in it, I'll just use the natural logarithm. And what happens when I ln e to the 0.09t?
It drops.
I get 0.09t. So the answer to that part of the question is ln 2 over 0.09. Which is about 7.7 years. then when it says, that's a two-part question, it says, how much will you have in 15 years? You're still starting with the same amount. Now we know, we know our interest rate, and we know the time of 15 years. And we want to know how much we're going to end up with. Do I need logarithms?
No.
No. I just typed that out. Looks like you have about $48,217.82. Is that okay? All right, who else found something? Looks like our attendance is bad today. Let's see what's going on here. We got Audrey out. All right, anybody have another homework question before we get out our review sheet? Robert?
Number 37.
37?
Yeah.
All right, let's look at 37. It says doubling time of an investment, and 37 is 7% annually, and I want to double my money. 7% compounded annually. What formula?
T per.
Per?
Oh, no, the A equals B.
Yeah, not if we're compounding annually. We only use per if we're compounding continuously. And I want to double my money. So what am I going to put in for A and P?
Like 10 to.
2 and 1 will work, 20 and 10, 200 and 100, whatever you want will work. And they gave me an interest rate of 7%. And I'm compounding annually, so N is 1. And I'm solving for T, so I'm going to need logarithms. So I'll divide by this number. Whatever you happen to have put there, you're going to divide by it. Oh, wait. That's just going to be 1.07, isn't it? So I'll take the logarithm of both sides. And the reason we do that is because as soon as we take the logarithm of this guy comes out here in front. So T equals the log of 2 divided by the log of 1.07. That should tell me how long it takes to double my money in this situation. I got about 10.24 years. Our review sheet. So that's in a separate packet. Remember I gave you 2 packets in the beginning because there was so much stuff. are a couple that I want to do to get started, and then I'll let you pick if you see something that. You want to do? The first one I want to do is problem number 2. The given. And somehow, based on that given, we're supposed to be able to find the log of 100. I'm on the first review sheet, the one that says Chapter 3 review sheet. This is problem number 2. For me, it's the first page in my packet. Chapter 3 review sheet. This is problem number 2. Any idea how I'm going to find the log of 100 from this given? Uh-oh, we're in trouble. Jenny? You know what, Jamie, that's a very doable thing. Here's the problem. This is made up information. And so if I found this X and this X, they are gonna match. This is completely fake information. So that is a good plan. That's a really good plan, except this is a no calculator problem, so I couldn't really do that without a calculator. And it isn't gonna work because I made this problem up. So it's a really good idea. What? It would be if the base were 10. Actually, it would be 2 if the base were 10. The log base 10 of 100 is 2. But I don't know, X is some generic thing. Okay? Robert?
What is the question asking? Like,
It says, okay, the log of 5 is this number. What's the log of 100? What's the number that goes right here? Well, would you agree that 100 is 2 times 5 times 2 times 5? And when I take the logarithm of a product, I can break that apart. What would this break apart into? Use your properties of logarithms. When you take the logarithm of a product, what does that turn into? When you expand that, what does that turn into? Addition. So it would be the log of 2 plus the log of 5 plus the log of 2 plus the log of 5. If I expanded it, because when I take the logarithm of a product, I add the logarithms. Well, what's the log base x of 2?
4.2.
And this is 0.56, and this is 0.12, and this is 0.56. So what would the final answer to the question be then? Check that, see if that's right. I think that's right. So how did we get that answer? What did we have to do?
Expand the logarithm.
Well, we had to break it down into 2's and 5's because that's what we were given. Right? These are the only 2 values we had to start with, so we broke down our 100 in terms of 2's and 5's. Okay, look at the second one. It says, what's this equal? break that one apart?
Yeah.
What would that break into? The log of 5 plus the log of 5 plus the log of x squared. Because isn't this 5 times 5 times x squared? So that would be 0.56. And that would be 0.56. What about that? What is that? 2. That's one of your properties. So that answer would be 3.12. Check my arithmetic. There's one more. Don't like radicals in logarithm land, so I'm going to rewrite that radical as to the 1/4 power. And what happens to it as soon as I do that? What do I do with that exponent?
Make it a coefficient.
Thank you, John. Yeah, we've done it like lots of times already today. It becomes a coefficient. When you take the logarithm of something to a power, the power becomes a coefficient. Now what about this? What am I going to do with this?
That just be 1.
That'll be the log of
2.
2 plus the log of x. So I have 1/4. The log of 2 is 0.12. And what's the log base x of x? 1. So I have 1/4 of 1.12, which is 0.28. Okay. All right, the other one I wanted to do for sure is number 6. For 5D, and 5D is y equals log x plus 1. We want to give all that function all those descriptive words. Domain, range, continuous, you know, all that stuff. So let's get a picture of this drawn first. This is a logarithmic function. What does the logarithmic function look like? BFF. It's like this. And what's that point right there?
0.
1, 0. Now, what happened with this one? We've taken that picture right there, that's the base picture, and we did this. What does that do to it? Moves it to the left 1. So instead of that dot being at 1, 0, that dot now is going to be at 0, 0. And instead of the asymptote being at 0, it's now going to be at -1. So there it is. All right, so domain. What's the domain? X is greater than -1. Yep, not or equal to, because we have an asymptote there. Just x is greater than -1. What's the range? All reals. Continuous? Yeah, there's no breaks in it. It's continuous. Increasing or decreasing?
Increasing.
Increasing. Remember, you're drawing it left to right, your pen's going up. Does it appear to have any symmetry?
No.
No. Bounded, and when we talk about bounded, we're talking about above and below. Is this thing bounded above or below? No. Its range is all real numbers, so it's not bounded. Does it have any high points or low points, hills and valleys? No. Does it have any asymptotes?
Yeah.
Yes, it does. And its asymptote is where x equals -1. End behavior. Now remember, the end behavior we're talking about as x approaches infinity and as x approaches negative infinity. Now, let's talk about this one first because it's possible. What happens as we go farther and farther to the right on this picture? What's happening to the y values? They're heading to infinity, yep. Now, we can't really talk about x going to negative infinity in this picture. Why? Because there's an asymptote right here, right? So if we're talking about what happens to it on the left, we would have to say not approaching negative infinity, but approaching -1. What is our curve doing as we approach -1? X is getting closer to -1, but what's y doing? Negative infinity. Okay? All right, those are the two I wanted to do. Now you kind of look through it. What do you see that you want to do? There's a lot of problems on here. This is due Monday. There's a lot here. So let's crank a few of them out if we can. Does anyone see anything, Robert?
Just like, what does it mean when it says sketch? Are you like, is that just graphing it like that? Okay.
That would be the sketch of 5D.
Can we sketch 5E?
5E. Now remember, the base of the logarithm doesn't impact the general sketch of the picture. So ln(x), there it is. I mean, that's your basic picture. What have you done to it? You just took that picture and picked it up 1 unit. Basically, it doesn't really look that much different. You just picked it up 1 unit. So this point was 1, 0. That it's not going to cross there anymore. It's going to cross somewhere else now, but that's it. So this will be the point 1, 1 because you're going to do that. We might as well sketch all these since it's quickly done. 1/2 to the x. This is a. 1/2 to the x. Okay, now that's an exponential, but we talked about this one day. That base is less than 1. So instead of being exponential growth, that's what the exponential looks like. That base is less than 1, so what's that going to look like? Decay? Remember, the base is less than 1, we decay. Y equals negative 3 to the x. Now, take the negative out for a minute. That looks like this. That right there looks like this. This is the exponential picture. When you put a negative in front of it, what does that do?
Flips it across the x.
Flips it upside down across the x-axis. So instead of looking like that, it's going to look like this. Okay, forget the 2 for a minute. What does that look like? E to the x. What does timesing by 2 do? Well, it's it's really hard to tell with our kind of sketching, but it just makes it go up faster. Makes it steeper, taller. So they're all sketched. We sketched them all. By the way, now it's going to be tough to do without a calculator if you have a base like E. But let's say you had this problem, or this one, and you weren't sure what it looked like. Could you plot points? Yeah. So don't forget that you can always plot points. It would be tough to plot points here if you didn't have a calculator, but certainly this one and this one, you could plot points if you had to.
Or 3B has a circle around it. So.
3B. The ones with circles are calculator problems,
Oh,
so that's why that's circled. It means you need a calculator to do it. So how do we do this? This is a pretty easy problem, Robert. How do we do this?
You just plug it into your calculator as a graph, or
I have a logarithmic equation with one logarithm in it.
would you just solve that?
I translate it into 6 to the x equals 21. Now you're looking at me saying, well, you still can't solve it. Where's your variable now? So let's take the logarithm of both sides. And then what will happen to that exponent? It comes out in front. So we end up with the log of 21 divided by the log of 6. Now, some of you are saying, you started with a log, you got rid of it, and then you put it right back in. Why didn't I just do it from this standpoint? What's wrong with base 6? I don't have it on my calculator. I need LOG or LN. So this is how we do it. So then type that in on your calculator. I'll get an answer.
Could you just go over when to use FV and when to use PV?
FV is when you are accumulating for the future. So it would be a situation where you were putting money into like some kind of savings account, retirement account, college account for your kids or something like that. PV is when you're paying off a loan. You have a loan and you're paying it off. Car loan, house loan, credit card loan, whatever. Anytime you're making payments to pay it off, it's PV. Making payments to get more, to save it, it's FV. Really?
Well, can we do one of the like word problems that I don't know if it would be on here? We have to like make up numbers because I don't get that one.
I don't know. Well, yeah, 8A. How long will it take to triple an investment if the interest rate is 3.2% compounded annually? What formula are we starting with? We're compounded annually, right? Yeah. So that would be this one. And it didn't tell me how much I started with or ended with. But what does it tell me? I'm tripling. So does it matter how much I start with? No. So pick a number, Lily. 10. If you start with 10, in this problem, you have to end up with 30. Point 032. Compounded annually, and it says how long does it take? So what's step 1? Divide by 10. So you're going to get 3 here. Is everybody going to get 3 here?
No.
Yes.
I think
Everybody is going to get 3 here. Because, Lily, the point is, whatever you start with, you're going to end up with 3 times it. So if you started with 6, you would end with 18. step one is to divide. Is everybody gonna get 3 here? Yes, because everybody's number here is gonna be 3 times their number here. So when they divide, they're going to get 3. You can start with whatever you want, as long as you end up with 3 times it. So you start with $1 and with $3.
Would you take off points if we just started with
Nope,
3?
absolutely not. Okay, so now we're gonna take the logarithm of both sides. And divide. Oh, so it's gonna take about 34.88 years to get your money tripled. Anybody see anything else you want to look at together?
Number 1.
A, B, or C?
All of them.
Well, I don't know if I get to all of them. I'll start with A. Write the exponential function containing these 2 points. What is my general equation for an exponential function?
Like x to the e.
No.
A b to the x, y equals ab to the x.
AB to the x. That's the format I'm looking for. Now, could there be e's in there? Absolutely. But the general format is AB to the x. So I've got 2 points given to me, and I have to figure out what my A and B are. Who remembers how we start?
With the 0.
We did about 30 of these. Yeah, we put in 0 for x and 2 for y. Remember me making a big deal about start with the point that has a 0? Because what's b to the 0?
1.
So 2 equals a. So now I know my equation is this. A is 2. So then what do?
Plug the next one in.
Get the other point. How do I solve that?
Divided by 2.
Yep. So 3/2 equals b to the negative first. What does b to the negative first be? 1 over b. So 3/2 equals 1 over b. So 3b equals 2 and b equals 2/3. So my equation ends up being y equals 2 times 2/3 to the x. Now I have a logistic function with an initial value of 10, a limit to growth of 12, and passing through 2, 2. What equation framework do I start with? Y equals what?
C over 1 plus abx.
C over 1 plus AB to the x. Now those letters might be in a little different order than I had them before. It doesn't matter. I need this one, and this one. So whatever letters you use, irrelevant. Don't worry about that. This is the framework. Okay, where do I start? What's the limit to growth? Where does that show up in this format?
C.
That shows up in the numerator, so you can just pop that in there. Now, it says the initial value is 10. That is the same as what? Your y-intercept. Very good, Dan. And that means this is the point 0, 10. Remember, in the logistic problems, almost always the exponent is time. So if we said the initial value, that would be when time is 0. That's your x-intercept, or excuse me, y-intercept, when x is 0, y-intercept. So let's plug that point in and see what happens. So we have 10 equals 12 over 1 plus AB to the 0th. So I put in the point 0, 10. What's b to the 0th? 1. So I basically just have this. How do I solve that? So 10 plus 10a equals 12. So 10a equals 2, and it looks like a equals 1/5. So now we've got y equals 12 over 1 plus 1/5 b to the x. If I plug in everything I've figured out so far.
You plug in the 2 now.
What do I do now?
Plug in the other.
Plug in the last thing I have, which is the 0.22. Now what? So 2 plus 2/5 b squared equals 12. So 2/5 b squared equals 10. So 2b squared equals 50. So b squared equals 25 and b equals 5. So our equation y equals 12 over 1 plus 1/5 times 5 to the x. A lot of steps there. Easy ones, but gotta be kind of organized. And then we're gonna write the equation of the logarithmic function that has been shifted 4 units left and 3 units up. So we're just starting with our basic logarithmic function. Four units left. How would you do that? 4 units left.
X plus 4.
So that would be log parentheses x plus 4. And 3 units up.
Plus 3.
That's it. All right. Anybody see anything else? Let's look at G for a minute. I'm not sure we've talked about that vocabulary. I think it showed up in some homework problems, but I don't remember actually ever talking about it. 8G. 8G. We have an investment with an interest rate 4.25% compounded monthly. And I want the annual percentage yield. Okay, what does the word annual imply? Okay, so we're gonna let this problem go for 1 year. We're gonna let T be 1. Compounded monthly. So N would be 12. And the interest rate is 0.0425. Do I know how much I started with? So let's just make it simple. Let's start with $1. And let's see how much we end up with. Start with $1 and see how much we end up with. Here we go. Do I need logarithms?
No.
I'm gonna put a few extra decimal places down there. Now here's what I want you to think about for a minute. What was our interest? 4.25%. So doesn't it make sense that I should have earned like 4.25? How come I basically earned 4.33? How come I earned more than the interest rate would indicate? What happened? How many times was I given that interest?
12.
And the interest that I was given earned interest itself. So in the second month, I got interest on the interest I got plus my $1. I got interest on my $1, but I also got interest on the interest. So after a year of doing that, Alex, are you awake? After a year of doing that, I actually accumulated a little bit more than I thought I would. My annual percentage yield was actually 4.33%, even though the advertised rate was 4.25%. So I ended up with 4.3 cents instead of 4.25 cents extra at the end of that year. Now, on an investment of $1, that's not a big deal. But what if that had been an investment of $1 million? Would that be a difference? Yeah, it'd be a big difference. That's the power of compound interest right there. So annual percentage yield is, what did you actually end up earning? The bank promises you this, but because of compounding, you actually earn more than that. Okay? Well, you need to finish the sheet for Monday. We've done quite a few actually, but there's quite a bit left. You need to finish that for Monday.
Is the quiz Monday?
No, the quiz is Tuesday. They voted to have the quiz on Tuesday.